In my last video, I told you all about the engineering and design process, what that looks like for our elementary students, and then perhaps even our older students who are being introduced to engineering and design for the first time. Today I want to show you a couple different STEM challenges that you may have come across while you're preparing some learning activities for your kids at home or even your kids in the classroom. But I want to show you how to take a STEM challenge, which is fun and engaging, and embed elements of the engineering and design process. The first challenge that I want to share with you is the paper airplane challenge. I've seen a couple different examples of the paper airplane challenge. The one that I'm going to focus on today is the cargo plane. So how much cargo can a paper airplane carry and still fly a certain amount of distance? I really like that challenge because I find that that one is a little bit easier to implement elements of the engineering and design process. So just as a quick review of what the engineering and design process is, it is a process through which engineers follow a series of steps to solve a problem, usually by means of a product that is designed to solve said problem. So looking through the cargo paper airplane STEM challenge, I don't really see a lot of elements of the engineering design process. Perhaps the ask at the beginning, which is the problem that the students are trying to solve, which in this case, can a paper airplane fly a certain distance while holding cargo of some sort? And then they try and add more and more cargo to see if they can still get to the distance that they're trying to reach. So there's our ask. How can my plane reach that distance while still carrying increasing levels or increasing weight with cargo? So there's our first step. The constraints and the criteria, that is a really great place for you as the parent or as the teacher to introduce elements of differentiation for your different age kids or students. So if you are teaching a group of students at varying skill levels, or students who have had different sorts of interactions with the engineering and design process, then you can add constraints to the activity for specific students or groups of students if you know that they can handle it. If you are working with students of different ages, like let's say you have a 6th grader, a 4th grader, and a 2nd grader, and they all want to design a paper airplane, then constraints are a great way to allow your 2nd grader to access the activity, but still proving some sort of challenge to your older 6th grade student, okay? A good example of criteria would be their plane has to transport at least $1 worth of cargo and change. That would be a great example of criteria. A constraint could be they're limited to only using, let's say, 4 pieces of tape and they can't use any more. And then, of course, you can increase the challenge so they have to carry at least $2 and change, or they can only transport quarters or something like that. So there's lots of different ways that you can differentiate using the criteria and constraints. So I would experiment with that and find out what works best for your group of students. So there's our first step, ask. The second step is to imagine. Now this is normally our brainstorming, where we are working with other kids or working with other people, and we're thinking of as many different solutions as we can, thinking as creatively as we can. Now with something like a paper airplane challenge, there's a couple ways that you can go about that. One way is that you could have, if you're working with a group of students, you could have groups of students work together in groups of 2, 3, or 4, and they share with each other different ways on how they can fold a paper airplane. That would be a great way to brainstorm. If you are working with kids at home and they have either the same amount of exposure to folding planes, or they simply don't know different ways that you can fold, I would find YouTube videos that demonstrate different folding techniques for paper airplanes. Now, word of warning, you do not want to give your kids, your students, ideas on the best plane design to build, because then you're taking away all of the creative problem-solving thinking processes that are necessary within the engineering and design process. So what you want to do are find videos that show the folding, show the different types of planes you can make, or find a book that shows the different types of planes that you can make, but do not show them using them. Don't find a video that says this is the best possible airplane, because which plane are they going to want to build? The best possible airplane. So find a video or find a book that simply shows them how to fold but doesn't show them the specifics of what the plane can do. After you've taken that time to brainstorm, you want your child to select the best plane, move forward, that they think will solve their problem. In this case, they're probably looking for a stable plane. Then we can move into step 3, which is the planning and design. At this point, you would want your child to explain their plan in whatever way that works best for them. They might even want to start playing with paper at this point, and that's fine, but we're not in our testing stage yet. This is our planning stage. So I recommend a diagram, sketching out an illustration of what they think their plane is going to look like, where they're going to put their cargo, how they're going to attach their cargo, and then any other materials that they think that they might need. And then of course at this stage you would also want to gather those materials. So if they're going to be using something other than paper or tape, if you have other ideas of constraints or criteria that you want to include, make sure those materials are available at this point. And moving into step 4, which is the step that all the children want to get to as fast as possible, which is our testing phase. At this point, you want to make sure that your children or your students have an idea of what a data table looks like, how to set up a data table and organize their data. You want to make sure that they're keeping their control variables the same, which would be their start point and their end point. They're going to have to measure, so that's another great opportunity to allow problem solving, is choosing the right kind of tool to measure, then measuring accurately. And to do this for your younger students or your younger children, I would recommend giving them options to a couple different tools, say a tape measure, a ruler, yardstick if you have it, and have them decide. And if they don't pick a great tool, if they don't pick a great method, that's okay. Let them choose. Maybe they're not so effective, and let them come to those solutions on their own. We want to be careful as parents and as educators not to tell our kids what to do, even if it's very clear to us what the best possible next step might be or process might be. We want to let our kids experiment that and problem solve through these unknown areas. So make sure your children or your students have lots of opportunities to test their design, to fly their planes, of course, to measure accurately, and then also to gather feedback. Let them try each other's. If you have that opportunity for collaboration, let them try each other's planes and give each other feedback. I really like your design. I think you designed this piece well. I noticed that it's not meeting this criteria, or you're not adhering to these constraints. I think you might need to adjust it in this way. Let them give each other that helpful critique and feedback so they can improve upon their designs, which moves us into our final step, which is improvement. I would recommend, after you've gone through your testing phase, to let your children or your students reflect on their own first. Let them take the feedback that they've received, the data that they've taken, and let them reflect on their own. What do I like about my design? What parts about my design are fulfilling the criteria or are solving my problem well? If I can fix, adjust, or improve any piece of my design, what would it be? You want to make sure that you are directing your children or your students with open-ended questions, not simply yes or no, not necessarily a rating scale, but you really want them to think and reflect about what they've done well and what they could do better. You can also take this opportunity to reflect upon their collaboration. If you have any kind of expectations about how children should be interacting with each other in your home or in the classroom atmosphere, then they can reflect upon those expectations as well. Now, I said that was our last step, but we know that the engineering and design process should be repeated multiple times until the student's design is as perfect as they think they can possibly be. So that question, that reflection question on what can I do to improve upon my design, if they're able to say anything, which chances are they probably will, then they need to go back through that process again and work to improve their design according to their reflection. And that might mean going back to the drawing board and sketching a new design, or simply just a couple tweaks here and there to make their plane as great as it possibly can be. So that's an example of how to take something as fun and engaging as a paper airplane challenge and embed elements of the engineering and design process. So not only is this challenge engaging, but they are also using problem-solving skills and critical thinking skills that will really push their learning to the next level. Another great one that I've come across and actually have used in the classroom on my own is the Catapult challenge. The Catapult challenge is really great because the design elements, of course, are super fun, engaging. But there's also the fun of catapulting, marshmallows across the room, and who doesn't love that? Catapult Catapult Challenge, again, is great in and of itself because it's fun, engaging, and they are building something. But I think we can use the engineering design process and embed it and make it even better. So this one I'm going to go through a little quicker. I would love for you to try and take this challenge and embed those elements of it on your own. But taking the Catapult Challenge, first introducing a problem with any criteria and constraints. So building a catapult. And I would recommend that either you choose or you have your child student choose, do I want to go for accuracy or do I want to go for distance? So your problem then would be designing a catapult that can shoot the marshmallow a certain distance, say 10 feet, or it will hit the target that you set up in such an area, and it hits that target so many times in a row. So one of those would be a really great problem for you to explore and solve. You would then have your child brainstorm either in a group or on their own. With something like the Catapult Challenge, you might want to find YouTube videos just like in the Paper Airplane Challenge. Just again, be careful that you're not finding videos that show them the best type of catapult or only one design or a best type of design. You want to make sure that they're only looking at videos on how to build them and not a video that would lead them to choose one particular design over another, because we want them to explore the different designs. After that, they would move into their planning and design phase where they would sketch out a plan and gather any materials that they might need. Then, of course, testing their design. Remember, you want to make sure that they're using a data table and they are recording their results and accepting feedback on what was working well on their design and what isn't before they move into their reflection phase. Again, I recommend that they reflect independently first before getting back with group members and possibly reflecting together. Keep in mind that you want to use open-ended questions when your children are doing their reflections, and that they can go back through the engineering and design process to continue to improve upon their design as much as possible. I hope this video has been helpful. I hope you're able to take either the Paper Airplane Challenge or the Catapult Challenge, embed those engineering and design elements so that your children can be using those problem-solving skills and those higher thinking critical analysis skills. I've attached links to both of those activities below. Now, the links that I'm giving you are ones that have not been adapted for the engineering and design process, so I'd really like to challenge you to take those activities and adapt them as best suited for your children or for your students. And of course, if you really like what you saw today and you want more of that for your child, Keystone Oasis Academy is still enrolling, where we do activities like these that take our students through the engineering and design process all the time. At this point, you're probably wondering why I've been wearing sunglasses throughout my video today. And that's because learning is really cool. I'll see you again soon.